Okay, so that's our agenda. So I'll be short for the transit-oriented development. So regarding the definition or the conceptualization of transit-oriented development, it's not a new idea. And also, I'm sure you have been reading examples or case studies, maybe locally or somewhere else. So feel free to, make a comment along the way if you see, some interesting example or, kind of related to what we talk about here, or the different variables. So by definition, there are, well, in general, this idea of TOD is about, again, this smart growth, making the transition from driving to, towards public oriented, like public transit, and they promote mixed use, high density, and all this pedestrian and cycle-friendly development around transportation node. And also there are, of course, different types of, TODs, and some are focusing on using the railway based, and others are focusing on bus based. And also I saw some recent articles talking about bicycle based TOD as a new way of promoting more compact development. And there are also different forms. I saw many case studies for basically cities everywhere within the US, in European cities, and some are doing comparisons. So today we're going to talk about Tokyo, so a Japanese city, which actually, for the places I have visited, I felt like Tokyo was one of the examples. Whenever I think about transit-oriented development, Tokyo was one of the examples I can, quickly relate in terms of, how they're implementing the ideas. And also so far, most of the GIS-related studies on TOD, they're all, well, not all about, but majority of the research are focusing on categorizing, or basically they're developing the TOD typology, because there are really different forms of the TOD development project. And the way they're doing is very similar to what we talked about last time. So they're looking at, for example, for a railway-based study, they're looking at each railway station, and then they're creating a service area surrounding each location. Usually it's network-based. So you can really easily create the service area surrounding each station, which is usually based on walking distance. So I saw many studies using half mile as a regular threshold. So they're creating this half mile walking distance service area surrounding each station, network-based, and then analyze different variables, including land use and land cover, within each service area. And also they may be looking at other socioeconomic variables and try to classify some TOD areas may be more towards employment oriented, and some others may serve other different functions. So today we're going to actually, that's the reason why I changed my background again. So that's a station in a railway station in Tokyo. And I also used Tokyo Station as my background for a while in the past. So this case study was an, it's not really 2020. I think it's just, actually I just realized it's May 2021. So I'm assuming it's kind of, I'll have to verify the year, but sometimes they do publish. But anyways, so for this new case study, and they're using, so in terms of the methodology, they're using, once again, the multiple criteria evaluation. So they're using this method to still like looking at the different types of stations within Tokyo. So they're doing a very, so they're basically doing this for 13 selected stations. We'll just look at the study area shortly. So just first of all, a quick idea on Tokyo. Tokyo was actually one of the first metropolis in the world to implement TOD projects. And it started all the way back in the early 90s after the bubble economy, and they started to rebuild the city, or kind of like growing the city through the railway system. So so usually you would consider the Tokyo station as the center of Tokyo, and then overall the pattern will be growing outward. And you will see, if you're looking at a land use and land cover or a population change map in Tokyo, so over time, you can really see the patterns very clear, all this development, all the population growth surrounding, like just following their railway system. And this is a map of their subway system. So you can see how busy they are, very complex. And some of the stations also serves the bullet trains. So, sometimes they combine all the different stations together. But today we're looking at within Tokyo. So they're mostly about the railway system, the regular navigation within the city. And also the paper actually reported railway accounts for 50% of the transportation market. So many people use railways to commute. And it's also, a very busy system daily. And some of the first pictures for Tokyo Station, I used to use the background during their daytime. So it's a very famous local attraction as well. So it's kind of this European style architecture. And also the size of each station is depending on which station you're visiting. So one thing I think is very different than, the railway stations maybe in some Western world would be a lot of these Japanese stations are fairly large. So inside the station, there are many restaurants or shops. So whenever you're looking, so this idea of transit-oriented development, so that actually points to one thing they're looking at within their study area. They're not only considering each station as a point, they consider the entryways and the entrance and also the exit as the major navigation points when they calculate network distance, because the size of them actually matters. And also when you consider the different types of services or the POIs, many of them are actually located inside each station. So it's kind of like an airport style railway station. And some of the other stations I visited, they're actually, so the railway station will be the first floor. And you don't really need to go out of the station. So the second floor may be a shopping center, and then the third floor, they're building some other, maybe, like a theater. So it's sometimes you don't have to go anywhere. You just take the train and you can really get one stop of everything. And there are also stations that are categorized by the working class. So there will be local firms and different companies surrounded, and some stations are for shopping. So, and also there are actually a couple of very interesting stations I visited in Tokyo, which might sound even like strange. And there's one station, so really in that area is mostly residential. And that station is featured by, so when they actually allow their travel flyers, and they will talk about the station, and the station is actually featured by a whole street of pancake restaurant. So it's kind of the Japanese style pancake, and there's nothing else. So it's a long walkway and the same style of restaurant, only serves the same kind of food. Okay, so let's look at their methodology. So they're doing a kind of like a three-phase research, but in general, the first phase, they are trying to, because I mentioned it's a multiple criteria evaluation. So the first step, they're identifying different criteria. So one of the actually the research gap they propose to fill is, they're talking about most of the existing research are focusing on categorizing or develop the typology for TOD. So instead of trying to characterize, and for example, looking at the land use and land cover, or looking at socioeconomic factors, their major contribution, or the major difference they're trying to justify is their specific criteria. They're considering the 4 dimensions: environmental, economic, social, and transit efficiency. So, and they're promoting the 4 categories, the 4 dimensions, and you can really, I will show you I think it's actually here, but we'll take a closer look at all the different dimensions they're looking at, different variables. So they specifically selecting the variables to reflect the idea of sustainable development. So all these different variables on the 4 dimensions, environmental, economic, social, transit efficiency, they're selected to quantify and to measure sustainability. So after that, the second phase, so this step called identify hierarchical structure of indicators, and to translate basically this means they're trying to determine the weights. And they once again used the AHP process, the analytical hierarchical process, to determine the relative importance. And that's what they refer to as hierarchies in their terminology. And for the second phase, basically you can apply the general idea of an MCE. So after they determined the weights and collected all the data, we'll show the data source, and they prepare each layer and do the calculation. And so since they're considering the 4 different dimensions, for all the different calculation, they're able to provide a environmental score, economic score, social score, and transit efficiency score. But each dimension is done through a lower level of MCE, multiple criteria evaluation, and they also combine all the 4 dimensions, all the different variables, and to finally compute a large score or a composite score combining all the 4 dimensions. And they also did a sensitive test. Basically, they just changed the relative weights for each criteria, and then they combine, and then they're re-ranking the 13 different stations, and just to compare. And what they found out is the top ranking stations, their ranks are fairly stable, even if they change the relative importance. So that's just kind of one way to justify, the validity of their research. And finally, they also did some analysis. So this part is more based on what they found out, and they look at the distribution of different facilities, and they also did a kernel density map for each station to compare, because the scores are really just overall, one score for each, or several scores for each station. So they also want to look into the spatial distribution. So that's the whole reason why they calculated a kernel density, so that you can look at spatially. So maybe they are okay with all 4 dimensions. However, they want to make sure, like spatially, they're also balanced, without too centralized at one particular location, because you want to maybe able to reach to more different areas. And here is a long list. I'm sorry if it's not very clear to see, because there are just so many variables, and in this article, so they have a lot of this like portrait layout tables and maps. So for this table, they're showing you all the different indicators. So by categories, the A category, so basically the A category represent the environmental factors, and the B represent economic, and they also considered social and transit efficiency. So for each one, they have a number of different indicators, and their data source are coming from both the official sources from Tokyo and also OpenStreetMap. So you can actually see they used OpenStreetMap, their POI data many times to characterize the different facilities. So within the OSM, actually one thing I wasn't so sure is because the table didn't really provide too much details. I know the OSM POI data will give you the category of the different types of POIs. For example, it's maybe bus stops or maybe parking lots or different other categories. But I wasn't really sure about the quantity of energy consumed. And they're talking about is to calculate the density of POI in the IPCA refers to the service area, which stands for the impedance pedestrian catchment area. So it's just basically the same term as station. Some research would call this as a station area, or some other would say service area. But it's basically a network-based area. Not exactly sure what this means, and maybe they have a category somehow referred to. So they didn't really provide too much detail on how this was computed. But I think for others are variables, it's pretty straightforward. They're either using an equation to calculate some indices, and they also used density many times, kernel density, to calculate the distribution of different types of, for example, parking lots would represent transit efficiency, and also they used some other facilities as well. I think I do have a slide. Okay. And here is a closer view of how they defined their IPCA, the impedance pedestrian catchment area. It's not very clear. And also they're just trying to show you a illustration of how this works. So it's not about all the 13. So I think they're only showing 7 or 9 here. So a closer look, this more irregular shape is their IPCA, which is network-based. And they use 1,000 meter as the threshold to define a walking distance. So basically, within the area, they would consider this area to be the service area for each station. So, and you probably can see there's also a more regular shape that is, in general, that is bigger than this IPCA. So they also did a buffer. So the buffer tool, as you folks know, if you did a buffer surrounding a point, that will be drawn in circles using the same radius. So for the buffer, they also did a 1,000 meter threshold. However, I think it's clear when we zoom in, like for example, for the Shinjuku on this station, it's not a circle, it's not a perfect circle. So that's just basically when they justified, instead of looking at each station as a point location, actually they did the buffer by considering, so it's actually a combined buffer instead of surrounding the center of the station, but actually surrounding all the entrances and exits of the stations. And also, since the size of each station is fairly large, because whenever I visited Japan twice, and both time started in Tokyo. So I felt like really, if you are going to Tokyo Station, you probably want to just be there at least 20 minutes ahead, because you just have no idea which way you go, and you maybe you enter from the south entrance and you realize your station is somewhere in the north, so you have to walk all the way up to the north if you are able to navigate. And I do feel like it's hard to because they have the Japanese character and Chinese, Korean that are pretty large, but it's hard to follow their English signs in general. So each time I would just have to follow. I would rather read their Japanese characters because it's easier to match. And also, by the way, because I know it's hard to, if you have, I wonder if anyone visited Tokyo before. Yeah, and then I guess all the names will be really hard to follow. It's really usually pretty long and very confusing. And also, by the way, the Shibuya station is, I felt like you probably have seen this crazy crossing, the Shibuya crossing, that people kind of like going 10 different ways. So the Shibuya station is basically the Shibuya crossing. So just to zoom in. So, and also they actually they compared the IPCA, the network, the irregular shape with the bigger buffer to assess as one way to assess transit efficiency. Because, so their justification is, so if your network distance is similar to the network distance, if your network station area is similar to the buffer area, they would consider that to be more efficient. Because in general, we would consider a circle is more accessible than a more irregular shape or a rectangle, because you can easily reach the center from all different entrances. So one way they're assessing this is to compare the size of the IPCA, the catchment area, with the size of the buffer. And so the bigger the ratio, so which bigger means closer to 1, basically the more efficient. So that's one way they're assessing the efficiency. And apparently they did their IPCA in ArcGIS, the network analyst, and the buffer tool is basically applied the same way. And overall, this is a map of their study area, all the 13 stations. So they selected the stations not only based on geographic location, but it's more through a qualitative process, because they're trying to categorize the overall sustainability score and the sustainability on the 4 dimensions for different stations. So they selected the 13 stations which they consider to be the most representative. And they're trying to do an assessment for all the different stations. And they didn't really offer, it just turned out the paper was still one of those typical GIS and very technical paper, and they didn't really provide too much information on analyzing the different stations. And they're pretty much all analyzing the different maps and data and the different charts. And they're using radar chart to show the 4 dimensions and how the scores are distributed. And also just for the map, the gray area shows the city limit within the city of Tokyo, but the larger red polygon shows you the Tokyo metropolitan area, which is a much bigger area that even spans into other nearby prefectures. So for example, in the zoomed in view, they actually have 3 stations selected outside of the city of Tokyo, but actually is still inside the Tokyo metro area. And the 3 here are all in Yokohama. And I do recall the lowest one here, the Minato Milai, and this is the station which shows the highest environmental score because it's a waterfront station and they have access to several parks nearby. And also, just basically most of the areas at the Tokyo Bay area, like what you can see here, like in those individual pieces of land, and they're all coming from land reclamation. So that's a very long-term historical trend in Japan, and it's a large area, forms a large area. So Disneyland is actually located on reclaimed land, and some of their storage ports are all there. They used radar chart, and they actually used radar chart so many times that I just couldn't even include all of their different charts. So for here, it's just an idea of how, so now the different dimensions are actually the 13 stations. And this is the green area. Basically, it shows the overall composite score, sustainable score, which they refer to as the TODNS. And they also have the second radar chart, again, for the 13 stations, and actually separate the 4 dimensions, the 4 dimensions of scores. And also, I do want to point out that I think it's probably sad to see that somehow economy is all the way bigger than and environment is pretty small. But I want to point out that it's because they gave environment criteria very low, not very low, but relatively low influence. And also, so that's, I would say it's only comparable on a relative scale. So you only compare between different stations as opposed to compared to, compare the social score with the transit score, because they're not directly comparable. They're actually on a relative scale. This waterfront station has the highest environment. And actually, I think overall, the Shinjuku station has the highest composite score even compared to the Tokyo station. And this is another major shopping district, very busy, and there are many large firms located there as well. And also you can see they're actually high on pretty much all dimensions except for environment, and based on the specific criteria they have considered. So in addition to the two radar chart here, the paper also compared, basically they did a radar chart for each station so that you can compare the 4 dimensions for each city and see which one is more balanced and which one is showing a particular, like maybe strong only in 1 dimension or less strong on other dimensions. And this is another very long map, and they did the kernel density for their POIs, and I believe it's a combination of all the POIs. So they're proposing using the kernel density to show the geographic distribution of all the different local attractions or different facilities, and including green infrastructures based on their definition and parks. And just to give you an idea of, so for the first row, including Tokyo Station, the 3 here are considered as balanced. In their terms, resource balanced, because they are, there's not really too much of a strong concentration at one particular portion. It's just overall well covered in terms, like within each catchment area. So what we see here, they're doing the kernel density map within each station's station area. And they also captured, actually many more are very centralized. You can see the stations with a strong center, but all the other locations without too much of a coverage. But they also identified a couple more with decentralized multiple centers where you see the multiple concentrations of POIs still using the OpenStreetMap data. And I think that's actually my last slide. So the paper was actually proposing the way to assess the different sustainability dimension. Just want to point out some of the future considerations for each station specifically. So what they propose as a macro level study, because they would have a specific score for each location, for each station, and so that they would be able to provide a future planning recommendations on maybe for a particular area, they can really try to enhance their green infrastructure design, and for some other stations, and they can try to balance their overall coverage within the catchment area. I'm trying to download the file Daryl sent to the chat, which
it's just the article.
Okay, cool, thanks. Yeah, I don't think I can really download because it stops all the way in there. Okay, so that's just my quick case study on a transit oriented development assessment. So many other research would use very similar ways to, first of all, delineate a catchment area, and then maybe use different classification algorithms, and they may use cluster analysis, or some used ANOVA to compare between stations as well. So this is one of the typical ways, and also another application of the multiple criteria evaluation. So instead of only for selecting a potential site for future development or for building something, you can actually apply the multiple criteria evaluation to assess existing locations, facilities, and then compare their relative score and doing a more spatial analysis on that. Okay, any questions before we move on, or any comments before we move on to the article review? We have 2 article reviews today.